what is a problem a lot of organizations face today when trying to use the potential of their data? As the pace of digitalization increases, the volume of research data is growing and the life sciences and healthcare sectors are becoming more patient-centric. Exciting new possibilities enabled by data, for example, deep insights or personalized medicine or advanced monitoring, they are becoming realities, but often we see only in theory. In practice, we see a number of obstacles still stand in the way, including the information overload from all sides, an overwhelming number of data analysis tools available today on the market, and a fundamental lack of data science experience, an undeveloped approach to data strategy and data harmonization, and final, the compliance, but also time-related risks of deviating from current standards in drug discovery and clinical trials. As a result, despite its abundance, data is fragmented and disconnected. The task of linking, homogenizing, and gaining insights from information require hard-to-find skill sets. So how will you be able to gain value out of your data? We introduce you to DISQOVER. The DISQOVER self-service knowledge discovery platform empowers researchers, scientists, and business users to link fragmental, internal, public, and third-party data sources with semantic search technology to quickly reveal previously hidden insights. With our latest release, the 6.0 edition, we offer even greater customization capabilities, improved user experience, and advanced integration methodologies, making the platform an integral part of your enterprise ecosystem. Powered by semantic search and an intuitive user interface, DISQOVER lets you explore and connect data from disparate sources to uncover new insights in a matter of minutes instead of days. This will enable you to master the flood of information, speed up research and go to market of new treatments and products, and homogenize, link, and reveal hidden correlations. So let's now take a closer look at the use cases and the platform itself. We are going to look into several use cases using only public data that you can work with yourself on our free community edition of discover.com. Philip is going to demonstrate use cases regarding the clinical trial study landscape, the identification of drug targets, how to search and review literature, image search by drawing a chemical, the identification of key opinion leaders, and finally, how to start a custom search from scratch.
So thank you, Marit, for the introduction. So my name is Philip Patton. I'm the scientific lead at OntoForce, and I will guide you through these 6 use cases. So I will switch from presentation mode to my computer screen, to my browser screen. So, and I will try to guide you here through the different use cases. So let me go back to the start page. So this is the default start page of DISQOVER. So this is a public version of DISQOVER, which is grouping a number of public data sources together. And so the idea, what we can do is also that you can install this version locally, which means in your private cloud or on-premise, that you can also integrate your internal data. But for this demo and for this webinar, I will show you here for 6 different use cases how you can use this public platform, which is actually open for everybody. So how does it go? Very briefly. If I click here on this data button, you will see here an overview of all the data sources we cover. What we have done is creating a layer on top of all of this data to be able to integrate the different sources and to allow you to search across different data types. What is a data type? What it means to do is, if I click here, for example, on PubMed, if you are familiar with scientific literature, you probably know PubMed as a resource of abstracts. So what it does is we ingest PubMed and we locate here a lot of information about publications. The concept of an abstract of a publication means or fits with the idea of a publication. So you have more than 30 million different publications, but also a lot of information about persons or person names, which are the authors of these publications. And so other types are also annotated to a lesser extent, but they contribute to the whole system. If I take a second source, for example, NCBI gene, which is gene-centered, you will see a lot of information about genes, 27, 28 million almost genes, but also relationships with publications. So a high number of publications here, not the abstract, the bibliographic information about the publication, but a link from a gene or multiple genes to one or more publications. And it's by doing this that we can create a network of information or a graph, which you will see here represented. Every data type is represented by an icon. So for example, the icon of this here with double quotes opening and closing means a publication, and you see like a spider web unrolling how publications are related to other data types. Every source is contributing to the graph. So for example, PubMed, you see here relationships between publications mainly and other data types. If I also highlight NCBI gene, you see another part of the graph. Combining these sources together shows you that you can gradually build up a graph. And that allows you to search across the different data sources. And the interesting thing is you can search all of this at once and see the relationships. So let me go back to the dashboard. This is where it all starts. So for the use case clinical studies that you see here in this box explained, we show you here how you can find recruiting phase 3 clinical trials for metastatic castration-resistant prostate cancer. So what does this mean? If I click on this button, I immediately go to the answer. So instead of just searching and exploring the data, these are a number of preset searches. So clicking on this immediately brings me to a dashboard which is showing this data. What is done is a number of search terms are entered and filters are set here. From the status box, we selected one item, recruiting, and from the study phase box, we selected phase 3 or phase 2-3 clinical studies. These items can be listed on different pages. So you see here that there are 2 screens or 2 pages here. So you can go back and forth and see all the items on the list. If I click on this button, I'm undoing the filter setting and I see that I will have more matching results. The number of results I'm seeing here are 28. 28 because I added 2 filter terms, but the normal number of hits are 1,300 approximately if I just take into account the keywords that we have searched. How is the keyword string built up? This is simple Boolean logic with some possibilities to do additional tweaking on specific terms or specific groupings of words. So we search for the abbreviation of the disease or the explanation in full text with the possibility to have a proximity measure setting. This is this tilde 20, meaning that we expect to find the words within a distance of 20 words. So that means that not the exact phrase or the exact term has to be matched here. It could also be a more complex way of representing this in a sentence or 2 adjacent sentences. If I'm clicking on a result here, so on the right here, you see the list of results. If I click on a single result, and I just take the first one as an example, you will see the details of the clinical studies that we are looking for. So we have 28 clinical studies here. And in this first result here, you see the title and then a number of pieces of information retrieved from different sources. You can open and select a number of boxes. But most importantly here, you can see here where is the data coming from if you're interested in the provenance. So the terms which are highlighted with a colored background, meaning that these are sources which are providing direct visible information in the detailed page. The ones which have a white background are contributing to the relationships, only to the relationships. This could be a combination here, but these are only contributing to relationships. So links to other data types. What are the links from the single result to other data types? These are highlighted here. So we can link to locations, organizations, facilities, measures, phenotypes. There is also a section uncategorized, meaning different terms which are less important or maybe less critical in the whole overview, but which could sometimes be interesting or could be uplifted by you in your local installation. What is also important if you do a text-based search is that you have the possibility to see where the search hits are found. So these are the properties of where the search hits are found. The label, the official title. So the label is what we are used what we use in DISQOVER to distinguish between different labels to make one preferred, or different names make one preferred, but the official title is a concept. You also see in the summary that certain terms are mentioned. So this can help you with finding where is a piece of information or a search hit retrieved. Let me close this and go back to the dashboard. So this is a relatively simple dashboard showing you the filter terms and an overview of the countries where the clinical studies are conducted. So a high number of clinical studies are conducted in North America or in Europe. This is the numbers that you see if you hover over. If I'm zooming in, I can go into the details, or I can represent these countries also as a list. It's just a matter of fact of selecting here on the bottom right a new property. Let me do this for something specific in North America. For example, here, if I click on this item, I can see here the facility locations. So if I select the facility locations on the left here, so these are the properties that I'm interested in, I have a number of possibilities of representing the data here as filter terms, a more analytics representation, or in other ways. Depending on the selection I make here on the left, I have a number of resolving or remaining analytics or filtering possibilities left. Unselecting this shows you all the potential visualizations that are available, but the system is smart enough to know if you have a certain type of information, what is best matching to represent this data. So let me go to a region overview. For example, I take the United States of America. So this is a very easy way of adding a new visualization. I can add it to the list, and I can double check here in more detail what is going on in the United States. And here you see a clear distinction between studies which are conducted in New York State or in California. I can easily modify this visualization. So this is just showing the number of hits in the different states of the United States. If I'm zooming in, if I'm clicking here on this menu selection button, I can change the values from the standard representation, the standards, just the counts of hits, to something more specific. For example, I can see here the number of enrolled people. So this shows me that the map is different here. For example, here in Mississippi, there are more enrolled people, or in West Virginia, compared to California or New York State. Okay, so this is a first representation. This is very easy to interpret the data. You can extend the information. What is now interesting in the whole system of creating a network is the potential of using the different relationships, the different links. So this small set of clinical studies are related to a few publications. If you're interested in viewing these publications, you just have to click on the item here. So this brings me to a second dashboard, which shows you here the different publications in the same way. On the right side, you see the results. In the middle, you see here the different filter terms. But let me go back to the start screen. So for the second use case, the use case related to drug targets, let's go here to the second item, the second box. So this second use case is related to drug targets, where we try to find potential information which could lead to new drugs, new insights about, which could lead to new drug assets, new insights about what to target next. This is just an example of what you can do with public data, but one of the strategies could be, show me, and this is shorthand written here, show me the diseases related to membrane-expressed protein kinases. So let's click on this button and we go to the specific dashboard, which is showing you the result of membrane-expressed protein kinases. So what is done here, a number of filterings are applied. We first filtered for Homo sapiens, the organism. This is hidden, so it's a filter which was set, but you don't see it anymore because it's not important here. We are focusing here on human health. If I'm clicking on this button here, you will see here the different filter criteria which are already set. So your search journey is also highlighted here. Organism is not visible anymore in the central dashboard, but you see it's selected. What is now important here is that we selected enzyme activities from gene ontology. So we bring here a lot of data sources together, actually about 10 data sources. If I'm clicking on enzyme activity, this is a tree structure. So enzyme activity is more specialized in catalytic activity. And if I further filter, you see protein kinase activity. This was the preset filter. Same thing with membrane. If I'm going to the gene ontology components, I see here the plasma membrane appearing as a filter criterion. By selecting the tree together, Homo sapiens and the different gene ontology types, you end up with only 189 different clinical studies. What is now interesting is that I can, for example, restrict my dashboard and say, okay, I'm not interested in all the rest. I can zoom in specifically on everything related to this 189. This allows me to focus completely on this list. Why have we chosen this? Because protein kinases are a very popular target class of genes and proteins, and membrane expressed proteins are also interesting because of their druggability, their accessibility. Now I can search for diseases because that was the use case. You see here associated diseases. So if I look for something, because it's a long list, I can go to in the filtering of my diseases to a specific group. For example, renal cell carcinoma. So for RCC, you see 11 genes popping up. So this filter criterion is selected, and my list of 186 is reduced to this list of 11. What is now interesting is that I can select here a single gene, ERBB2 for example, and I can take a look into the details of that gene. Same thing again. You can highlight the different sources. You can see where every source is contributing with color codes. So these are all different pieces of information coming together. And you can take a deeper look into potential mentioning of diseases, etc. But what is now interesting also is in this view here, and that's, I can close this here, is a Sankey diagram, which shows what are the relationships between the associated diseases and the different processes the genes are mentioned. So for example, if I'm interested in cell migration, I see here which diseases are related to cell migration via the associated genes. If I'm further scrolling down, I see here the links to related data. The links to related data are showing here a specific class of a dashboard where you see the gene-disease associations. So this allows me to dive into the relationship between genes and diseases. So let me click on this. What you see in this dashboard is a very detailed representation of all the 11 genes here. So the list is filtered for 11 values. You see the list of 11 genes that I selected with all the diseases they are associated with. But there are many different specific relationships mentioned which have different annotations. For example, you can make a distinction between evidence levels or say, okay, I would only like to see direct targets. So this allows me to filter specifically for more relevant information. And then if I click here on a single result, I see here a detail about a relationship between a disease and a gene. And the relationship is potentially associated with, which is not so strong, but the evidence level seems to be quite high. The details of this information is coming from open targets. So you see another source we have included here. Okay, by doing this, I follow the link and you see that 2 tabs are created here. I have one dashboard. I can always go back to my previous dashboard and you see that they are grouped together in one search. Same thing with what I showed you before. So let me go back to the dashboard again, the central start page. So publications, the third use case. Publications are very interesting and very important in initiating search, in discovering what is available, what is already existing, and what is new. But it also poses a problem because this information is mainly unstructured. Humans, as a human, you have to read the full publication to really interpret this at its fullest. So that makes it very important that you do, if you do a search, that you do a proper pre-selection before you go into the deep reading of an article. So searching and searching strategies are very important here, which can help to rule out as soon as possible or as quick as possible less relevant publications so that you can focus on the most relevant ones. So what is the idea here? If you do a literature review or a deeper investigation, that you're able to use DISQOVER here to find more related data. What is like a search strategy that could be used here? Again, a specific search is listed up. Show me all articles which are related to EGFR, drug safety and comparative effectiveness. So EGFR related drug safety and comparative effectiveness. If I click on this, it means that it will search for these specific terms, but in a combination here. Again, we used a certain Boolean structure here. You don't have to use this, but this opens some more flexibility of finding safety and drug safety together in a vicinity, in the proximity of 10 words. Same thing with comparative effectiveness. If you're looking for the exact match, the exact matching term, you can leave out the tilde and 10. And then EGFR. So what you see here is, on this dashboard, are a number of representations of the publications in time. And you see the incremental number of publications, which are showing here on this axis, on this x-axis, the years and the number of hits here. Same thing with the journals. You can take a selection and see here which are the journals which are mostly reporting about these search hits, and then you see the list. Also citations which are mentioned, and a publication date filter is another representation of this in a more compact form where you can use the slider and quickly go and say, okay, I only would like to see the most recent publications. Now the publications are listed not just on the right, that's still possible, sorry for clicking here. So I can still show all the publications on the right, that's possible. But I can also have another representation on a broader view where you see here the title of the publication, some information about the publication date and the journal, but also direct links to external databases or external websites. So this is a very important part of DISQOVER, the possibility to link out to other related sources or the original sources. Okay, this helps me with filtering on for certain criteria for quality, the number of times a publication is cited, or maybe the how recent the publication was available. For example, if I'm selecting here some new or more recent publications, I can click on a certain certain publication, and you see here the summary of the information which is retrieved from mainly PubMed. Same thing here, you can specifically find here in the abstract where the different terms are mentioned. And this allows you to search for the most relevant publications, or at least screen quickly for the most relevant publications. Okay. This was use case number 3. Let's go back to the main dashboard. Chemistry search. This is another type of searching. This is an extension of the possibilities of searching with purely in a text-based way with another input method. So what does it mean? You can draw a chemical structure or cut and paste a chemical structure in this canvas. you can execute a type of search with a technology of your choice to do an implementation of what you're looking for. So allow me to just draw a very simple molecular structure. For example, this. I can select similarity search. I can set some preset filters or selection filters, and I just execute the search. And what happens is this structure is represented in a string format, is sent to the service executes the search and answers back. The results are shown here in DISQOVER. So this is an alternative to text-based search, and this can extend it in different ways. We show this here for chemistry search, but we also are able to work with nucleotide search, for example, or protein search. So for example, having a BLAST server linked as an input method, you upload a file, you execute a BLAST search, a similarity search, an alignment search, sorry, for nucleotides, for example. You get the matching nucleotides as a result, and these, if they are integrated in DISQOVER, can be represented as piece of information which could be related, for example, to research projects or other related data. In this case here, for chemistry search, we find one hit because we did a similarity search, and that's what is available in the system. If I'm clicking on this, I'm going to the dashboard, the chemical dashboard, and you see this is catechol. This is what I expected. I can click on the molecule, and I see the data and related data all together. So this is a structural representation. These are the names or synonyms. This is a description. And these are all the sources which are here brought together. What is important here is that we have links to other related data to continue your search. In case you have your own internal data added, it could be a link to, for example, the projects where this molecule or this structure is involved in, maybe a storage system, an ordering system, whatever you have in mind is possible if the data is available. Maybe important here, how to represent what something is, how to represent the content. We use identifiers, and this is for everything. So this means that this catechol can be represented with different identifiers. Could be, for people who are familiar with this, a smile string, an identifier coming from CAS, another representation. If I'm clicking on this button here, you see here the different representations of the different identifiers for this molecule. So using one of those can help to uniquely identify this concept, catechol, and to annotate it with your own internal data. If you do that, you get all this information related to that on top of your internal data associated with catechol. Okay, let's go back to the start page. The next use case is person search. So how to find domain experts or key opinion leaders in a certain, via certain sources. If I click on this button here, this will lead me to an in-between page, which shows you different possibilities to search for. For example, find authors and publications in authors which are mentioned in publications, or people who are related to projects, could be principal investigators or the study supervisors. Clinical studies, same thing here. The physicians which are involved in the study maintenance or study overview, or people who are mentioned in patents. So let me search on a very general term, microbiome. So I'm interested in finding information about people who have published a lot about microbiome related data or the microbiome, and to see here, if I click on this, over time. So I'm clicking on microbiome and publication, and you see the list of related publications here. It's a long list, 36,000 different publications. You have the journal titles, which are mostly mentioned. You see also the steep increase of the number of publications with a slightly lower amount, but that's just because we are at the beginning of 2020 still, and then some mesh descriptors. In the meantime, the long list of author names is generated. So what does it mean? I'm focusing here, for example, on recent publications. And I'm showing you here a hierarchical tree of all the different author names. I could also represent this in another way. For example, show me the author names just as a list. And this shows me here the different names of top authors. So now you see here some top authors popping up, and you see, for example, that specific persons here have more than 100 publications in the last years. And you see here the names popping up of top authors in that specific domain. If I'm selecting one or more of these top authors, I can even go to their specific publications. So let me select 200 of these publications and see here all the publications mentioned, where these authors are mentioned as last author, first author, whatever. And then if you open one of those publications, you will see here, first of all, where everything is found. But secondly, also, you will find information about the related people or the annotations here of the authors. This can be done in a similar way for the other data types, clinical studies, patents, and projects. This is a similar search strategy. So this brings me to the last use case, custom search. So for custom search, you can just start exploring the whole system. So clicking on this shows you the big graph. That's where I started with. Here you see the overview of all the results we have for every data type. So 31 million persons and person names, publications, genes, variants, etc. The moment I'm typing a search term, for example, microbiome, you will see that the graph will be reconstructed. So the search is executed, and only a subset of the graph, the local subset of the graph, which is relevant to microbiome, is now represented. So instead of having millions of different results, it's now more into the thousands. So 36,000 publications, a number of clinical studies, etc., etc. Here again, the same thing. You can see here where you can find the different relationships. This allows me, for example, to go to other hits, like things which are not directly related to the literature, but which are related via the literature or via other ways, for other terms, to different data types. For example, I can link here to research projects. So by clicking on this, I find all the research projects originating in Europe and in the United States, because these are the main sources we cover. The exporter source from NIH, and then FP7, FP6, and Horizon 2020 studies. And these are mentioned here in all these, in this dashboard, in all this information. So you can, for example, quickly select here the pieces of information you're interested in, and then see a smaller list of results. For example, if the funding organization is important here in your selection criterion, you can say, okay, show me everything which is sponsored by NCI, and you find the different projects again. You see here things with similar names. That's mainly coming from different fiscal years, where summaries are published about these clinical studies, about these projects, sorry, and then you can read through this and you find the related data. For example, the abstract of the project, the funding which was included here, and related data about the people or results which are published in studies, in clinical studies, or as publications. Okay, this is in a nutshell what we can do here with the custom search. It can drive you in many different directions. You can follow the links, you can save your results, and if you want, you can just start off from where you left if you log in again, because on the left side, you see all the previous work I've done. So I can go back, for example, to the very beginning of my search. For example, this representation of finding certain clinical studies and related data, certain publications about clinical studies and related publications. This is all information that I can go back into.